Good morning, everyone. This is the monthly meeting of the IHS, the Institute for Historical Study. And today we have a presentation by Dan Kohanski. Dan is a member of our board, and he was a professional programmer for over 35 years, one of the senior programmers on a critical project at the Bank of America from 1993 to 2004. And was intimately involved in crafting its solution to Y2K, which is good, gives him a good background for the discussion he's going to be giving us today. His first book, The Philosophical Programmer, was published in 1998 at a time when Y2K was already coming to public attention. His most recent book, something very different, A God of Our Invention, is an examination of the history of Western religion. And that one I have read and very much recommend. So, up to you, Dan.
All right, well, thank you, Jim. If I could ask everybody, I think everybody has muted except Brian and Jim. I just want to add before I go into my presentation that we do this every month except in December, and I have everything filled up through October. I think I have everything filled up for the rest of the year, but there's always 2026 if anybody wants to do a presentation. So let me share the screen here and bring this up and start a slideshow. My apologies, for some reason Zoom died on me. So let me try that again. Good, everybody's there now. Okay, are we all together here? Can you see my screen? Good.
Yes,
So
we can see.
Y2K is short for Y2000, K being kilo or 1,000. And is known as the Y2000 problem or Y2K because it was going to hit the world on January 1st, 2000. And I'm going to discuss some thoughts on what it means at the end of it. But I'd like to start, being this is a historical group, with an earlier historical incident. In the year 1000, at the end of 999, many people thought the world would end. Some people sold all their possessions. And some gathered near St. Peter's. This was St. Peter's. This is not the one we know now. That was built in the Middle Ages. This was the year 999, St. Peter's. And the Pope at the time was Pope Sylvester II, who was probably the most brilliant intellect of the age. Here he is giving lectures before he became Pope. And he was known, among other things, for being able to use an abacus. Intellect was not exactly current in that time. It was very suspect, in fact. So there were some people at the St. Peter's Mass waiting to see if he would sprout horns and a tail, as in this image here, where he's consorting with the devil. Needless to say, he did not, and the world did not end at midnight Mass and did in fact continue. Which brings us to our current situation. So I'm going to give you a very short lesson in how computers work, because you need to know this to understand why Y2K is such a problem. I'm going to start with a quote by one of the great philosophers of computer science, 𝘠𝑗 𝘗𝑩𝘓𝘓. He wrote this, I believe, back before 1970. And you can read it. The point basically is that when you look at what a machine can do, any machine is a tool. The computer is a tool that is limited only by what man can think. So let's talk about what man can think. How do we tell a computer what we are thinking? Well, computers only understand machine language. That's ones and zeros, on, off. For example, if I want to have a computer do a subtract of two numbers, there might be a binary instruction, which is 0101. I'm making this up, you understand. And the first computer programs were actually written in binary. This was not going to work very well. So we developed assembly language. Instead of 0101, we would write SUB, and then there would be an assembly program to convert SUB into 0101. So here's an example of assembler code. We move price into a register, we subtract cost from price, and we move from that register into profit. But every computer has its own machine language. So here's another one: load, sub, store, or sub long, price, cost, profit, all in one line. The point being, every computer has its own machine language. So here's an early computer, the IBM 704. This was produced in 1954, and you can see how big it is just by looking at the person sitting there, not to mention all the tapes and stuff, and the cathode ray tube sitting around it. In 1957, this was the last vacuum tube computer, the IBM 709. In 1960, we have transistorized computers, the IBM 7090. I picked these examples for a specific reason. If you want to write a program on the IBM 704, it's not going to run on the IBM 709 because it's written for the assembly language or the machine language of the 704. So how do we do this? Well, we could rewrite the program. But rather than do that, IBM wrote an emulator program. This is a program that runs on the 704. It simulates the 709. I'm sorry, on the 709, simulates the 704. So now our programs that were written on the 704 can be moved to the 709. But we had the 7090. So now we have programs written on the IBM 704 running on a 704, 709 emulator, which is running on a 709, 7090 emulator. The point being, it was easier to do this, or conceptually, than to try to rewrite the programs. Keep that in mind for later. We have another problem with assembly language. Aside from that, it only works on one computer. It's very, very easy to make mistakes. So we invented high-level languages. We wrote compilers. The first successful language is Fortran. You may have heard of this. Formula translation. It's a mathematical language, where there's actually says x equals a squared plus b squared. The double asterisk means exponentiate. Businesses didn't like that. They wanted a language geared to their way of thinking. So we invented a language you may have heard of, COBOL, which stands for Common Business Oriented Language. It's oriented toward business thinking. This is how man thinks. We're going to tell the computer how we think in business terms. Example: subtract cost from price, giving profit. That makes sense to a businessman. You have a price, the profit is the price minus cost. Well, we write it this way, or we can write it this way, later versions, when they discovered that you needed subtract cost from price was a little too cumbersome. Compute profit equals price minus cost. Makes sense to a businessman. COBOL was developed in the 1950s and was in widespread use by 1960. In fact, the Defense Department then required that many of its programs must be written in COBOL. The Department of Defense was probably the single largest consumer of computer programs. The IRS is pretty close, but think about it. This is where they decide they want something, it's going to be done the way they want it. So here's a standards manual from April 1960 on how to write programs in COBOL for the Department of Defense. The result being, by 1970, COBOL was everywhere. COBOL shows the power of the computer because now our businessman thinks profit is price minus cost. We understand that. We can figure out how to make the computer understand it. And we can move, if we had COBOL in 1954, if we had written computer programs in COBOL on the IBM 704, we wouldn't have needed the emulator. We could just move them to the 709 and the 790. I'm simplifying, but that's okay. But COBOL shows that we focus on how we think. The problem with COBOL is programmers like to think in decimal, not in binary, which is how computers think. And now we come to the big problem, computer memory. Computer memory, which is what the computers use when they're actually, the processor chip in a computer works only on memory. If you want to do subtract two numbers, those two numbers have to be in the computer memory. Memory is divided into boxes. The various boxes, 6 bytes, 6 bits, 7 bytes, 7 bits, 8 bits. I once worked in a computer with 36 bits. Gradually, we settled into the 8-bit. This is a box that holds 8 binary bits. 2 to the 8th is 256. So it holds a box between a number between 0 and 255, or if we make it in not in plus and minus, it's an absolute number to 255 or minus 120. See, it's a limited number, but it's a useful number. So back to IBM. In IBM 1964, we introduced the System 360. This is the model. It ran 320, 360, 20, 30, 40, 50, 60, 70, and then later there were all kinds of others. And then there was the 370. But right now we have the 360. This was one of the common models. You can see the size of it. The most expensive version of this model had 500,000 bytes of main memory. Each byte was 8 bits, okay? This is what a memory unit looked like. There were up to 4 of them. It holds 128,000 bytes, kilobytes, and it weighed over 600 pounds. Here's an idea of what the size is. That's a screwdriver. You can see the screwdriver handle. By way of comparison, what we used today, that's held in your hand, 32 gigabytes. 250,000 of those 600-pound kilobyte box would be needed to hold what you hold in your hand now. Same thing with data storage. Data storage is where we keep information that we need, but we don't need it immediately. And we keep it on disks. We can keep it on a tape. You see a tape in the background there. These are removable. So we can put storage offside and put it on when the computer needs it. This is a 2311 removable disk drive. 7 million bytes. It's a lot more than memory, but still limited. Very limited. I hold this in my hand. It's 2 terabytes. 275,000 IBM 2311s would be needed to hold the same amount that's in one of these disks. Memory has changed. Computers have changed. But in the early days of computers, memory was expensive and very scarce, and data space was expensive and just about as scarce. Now, let's go back to COBOL. How do we store a date in COBOL? Remember, they think in decimal. So here's a date. We use a separate box for the month, day, and year. December is 12, 18, 19, and 60. Why 19 and 60? Remember, the highest number one box can hold is 255. So we need 2 dates for the year, 19 and 60. Boxes are expensive. But here's a thought. This is how we normally write a date when we're just working on dates. So let's store the date that way. Makes sense. How to make a date calculation. I have a mortgage. I made a payment back in December 1960. There's the record of it. Comes next year. The computer's going to check on January 2nd. Is my next payment due? Well, no. 60 is less than 61. So it's only 15 days. Now we have a problem. Suppose I made a payment on December 18, 1999. 𝑘121899, same storage. But it's going to be 2000, not 2000, 00. I'm 100 years overdue. By the way, this is important. It's not a millennial problem. It's a centennial problem. If we've been using computers since 1850, this would be the Y1900 problem. Okay, why didn't anyone notice? And this is where it gets interesting. People didn't think they would be still using programs. Remember the example of the 704, 709, 7090? The example didn't sink in. 1970, we didn't think we'd still be using programs, same programs, 30 years later. Because COBOL can move from computer to computer to computer, kept using them. They also forgot about the data. Programs can change, but the data out on those disks and out on those tapes is still using 60 for a year and not 1960, because that's how it got on there and that's how it stayed, and we still use that data. And again, back then, hardware was expensive, software was cheap. It's the other way around now. Well, if it's obvious to us, 1999 is older than 2000, why can't a computer see that? And this is another thing. Governments and corporations had all kinds of projects going on all the time. They were always doing new things, many of them critical. We can't take valuable resources, which nowadays is programmers, to fix a problem, but it's 30 years off, it's 10 years off, it's 5 years off, it's 2 years off. In 1984, when it was 16 years off, the first guy who kept nagging about this got fired because they got tired of listening to him. Well, we did solve the problem eventually. And here's where I'm going to get personal for a minute. I was working for Bank of America, as Jim says, from 1993 on. And in 1998, the bank decided, well, we better take a look. And there were some people I knew had been nagging them for about 4 years. They didn't get fired, but they weren't much, they were kind of ignored. So we took one of our test computers, we cranked it up to December 28, 1999, and let it run for 3 days. And on the third day, no, it did not rise again, it collapsed completely. Things went haywire all over the place. Mortgages 100 years overdue, all this, all that. Dates are critical to almost everything anybody does in banking, in the IRS, in anything else. So in October 1998, we passed the year 2000 Information Act, which also kind of limited the liability if you didn't get it right, but at least it encouraged it. And here's the thing. We solved it so well. I spent a year and a half from July 1998 to December 1999 working on fixing it along with a bunch of other people. They pulled me off a critical project. They put that aside, and they had us all work on this. And at midnight, December 31st, 1999, I was down in the bank's computer center, the online, the actual data center, just in case something went wrong. We were all down there. But it actually took between $100 and $600 billion worldwide. Estimates seem to vary a lot, but you can see this is not a simple fix. And by the way, not all the fixes were permanent. By permanent, I mean until the year 9999, 10,000 years. I think that's a safe way off. But some systems, some solutions only work until 2020 or 2030 or various jiggering fixes because they didn't really solve. And that leads to the general problem that Y2K illustrates. The end of the 1999, I wrote this for the Chronicle, which published it 3 days before. And yeah, I think I was willing to predict, go out on a limb and predict that, yeah, we'll survive this. But it would be a pity if we allowed our escape to let us go on thinking we have nothing else to worry about. Unfortunately, I had to say I told you so, but I told you so didn't work. Here, for example, Paul Krugman, fabulous guy. He's talking with Nathan Tankus, who's a computer expert. I picked this up from about 2 years ago. Tankus is saying, well, you know, when we had COBOL, when we had to figure out how to do unemployment, it was too technically complicated to calculate because COBOL systems were complicated. So they just put $600 a week to everyone's check. And then Krugman chimes in. He remembers in New Jersey, there was a desperate appeal to people who knew how to program in COBOL because nobody knew how to do it. By the way, most programmers hate COBOL. It's a lousy language, but it got there first. The Defense Department liked it. They put out all kinds of contracts for it. It's still in use. Here's a GAO report in 2023. They identified 10 critical systems. This is legacy systems like in the IRS mostly and in other places. 8 to 51 years old. Remember the 704, 709, 790 example. 51-year-old programs. Nobody knows how to maintain them. Nobody knows how to read them, so they can't get rid of them. Because we have a decrease in the availability of individuals with a proper skill set. That was 2 years ago. We're still doing it. And now I have to get a little bit political because Musk and his Doge crew have informed us that in 7 months, they are going to replace the COBOL systems that run the Social Security. And yes, COBOL still runs Social Security. They're going to replace it in 7 months. I have replaced COBOL systems, less complicated than Social Security. It takes years. And even then, it takes a lot of testing. The Bank of America is known, by the way, for being very meticulous about testing. Other banks would just slap a system in. We would test the system for 6 to 8 months before we'd let it go live. And there was a good reason we did, because there were a lot of problems. So I just want to throw this in because it's so delicious. Voyager was sent out there around 1970. It's still out there. It still works in Fortran code. And they still figure out how to do it. Well, that's because they tested it to a fairly well, and they knew it, and they didn't let it go out there until they actually fixed it. But it's not that big a program. But I thought that was neat. So in discussion, first I want to bring this up. In COBOL, in almost any program that deals with dates, you don't always know what the date is. So when put in 0 for a date. When COBOL started in 1970, they figured in 1960, nobody's still alive who was born in 1875, which probably not completely true. But they used 1875 as an unknown year. So when Doge announced, we found people who are 150 years old collecting Social Security, this is obvious fraud. No, it was COBOL saying, we don't know when they were born, we're going to say they were born then, and the programs were written to understand this. But Doge, which wants to replace the Social Security system in 7 months, didn't understand it. Think about that for a minute. Think also about AI, artificial intelligence. This is going haywire. Nobody's really controlling it very well, though they're starting to try to. But again, think about all of the sloppiness that went into the year Y2K problem, all of the sloppiness coming out of it, all of the lessons learned that we haven't completely learned yet, and then think about what artificial intelligence is going to do. Those are the lessons I want to take away from the year 2000 problem. And now I'll throw the floor open for discussion.
Yes. May I ask, you mentioned Elon Musk and getting rid of all COBOL programs within 7 months. And I think you implied, I mean, for Social Security, and you implied that would require actually years of preparation. I mean, that's a major concern. Nothing he or his his superior would attempt would surprise me, but it seems the brink of idiocy to attempt that. And I'm just wondering what kind of publicity, should we not attempt some publicity and cautions to suggest some alternative strategy and alert people to this?
Okay, let me talk about that a minute. First of all, I have replaced old computer systems, programs with new ones. Before you can put a new one in, you have to thoroughly understand what the old one is doing. In this case, that means a thorough knowledge of COBOL. I managed to get away without doing COBOL. Other people did that. I did other things. That's part one. Part two is I did this for a private company. Private companies have to answer to the board of directors, their stockholders, management, but that's about it. If you want to replace a government computer, you have to answer to Congress. And the problem with that, and I'll use the IRS as an example because this actually happens. The IRS, I think, is no longer using computers that were built in the 1960s. But in the 1990s, they were still using them. Why? Because every time the IRS settled on a contract to replace the old computers, the losing company would contact its congressman and say, no, you have to let us get it, or you have to stop this so we can try again. And this happens all the time in government. And that's excuse me, moving a cat. That is one main reason why the government is so slow, is slower than companies in replacing computers. Having said that, I will also say that the computer contractor, the developing company that the Bank of America worked with, had its own problems. And I used to tell the bank, my supervisors, they will do one of two things. They will produce it on time, or they will produce it in a way that works, but they won't do both. It took several iterations before my supervisors finally agreed with me. So this is a problem that is not just limited to government. Computers are the most complex things we've ever tried to do. There are certain tools we have now in the 20 years since I left the business that make it easier, but you have to still know what you're doing, and you have to be willing to take the time needed to get it right, even with new tools. And again, in replacing these old systems, which are 50 years old, you still have to know how those old system works. There was a science fiction story I read once about this guy who decides to take a long sleep, let himself be frozen for 300 years. And then he does this in like 2030. They wake him up in 2099, and they say, we're really sorry to wake you up ahead of schedule, but you're the only COBOL programmer we could find, and we need you to solve the year 2100 problem.
Well, I still didn't quite hear the answer to my question, which is that, and you're implying that despite Musk's announced intention, we don't have to worry because you implied Congress will.
Oh, no, quite the opposite. We do have to worry. Musk has cut Congress out. Musk is also of the move fast and break things theory.
Well, no, I agree. So the question I'm raising, let me put it this way. The question I'm raising is, what can we do to stop this or to publicize this? What can be done?
Oh, well, in terms of that sense, we're getting political, and this is a nonprofit historical society. So I'm going to raise the question, but I'm not going to ask you I'm not going to answer it. Take that discussion to a political group, okay?
According to our billionaire,
how I can see historically there will be problems.
According to our billionaire Secretary of the Treasury, we don't really have to worry. I mean, his mother-in-law, if she doesn't get her Social Security check for a while, she won't complain.
Yes, well, her son-in-law is a billionaire. Of course she won't complain. We're trudging on the edge of politics. As I said, I want to explain historically why what they're trying to do in the government is a problem. but I'm not going to solve it because that gets into politics and we're a 501c nonprofit.
So back in the day, I mean, you were in a position to really understand what the dangers were and what they weren't. I remember I had a friend of a friend sold everything she had and went off the grid and built a bunker in the wilds of North Georgia. And there were a lot of people who really took the world was going to end very seriously. What was your perspective on it? Did you have any doubt that well, you knew that the Bank of America was on track to not have problems, but did you anticipate?
We were about in the middle of the pack
Mhm.
in terms of waking up and getting into it. I don't really recall at this point. We weren't the first, we were nowhere near the last. And it took us the whole 18 months that we were, because we have a huge number of systems. They now have a huge number of systems. When I went many years later to work for the State Department as consular officer, they had all the systems then, and this is not 2012. A lot of their systems work at dates. For example, simple example, if you file a petition as a permanent resident but not a citizen to bring your relatives into the country, that doesn't go into effect immediately. That goes into effect on a quota system. Your petition matures after a certain number of years. Obviously, and depending on what country your relatives are coming from, by the way, there's a scale. Now, obviously, that's a date calculation. So right there, State Department had to deal with dates and figure out how to recalculate them. They managed to do it, at least by the time I got there, they had fixed it. I don't think the world would have come to an end. It would have been very, very difficult. But the world was not going to come to an end any more than it came to an end in the year 999. And by the way, many people sold all their possessions, gave everything they had to the poor, went to confession, made sure they had checked off all the heavenly boxes to get right with God before the world came to an end. So yeah, this has happened before. And we survived that one too.
As I recall,
we would have survived. It would have been a lot messy. And I think there were some problems. By the time it came around to us in San Francisco, the year 2000 had started about 18 hours early in New Zealand. It's like the first time zone to hit New Year's. So by that, and then it goes to Australia and Asia and Europe, and the East Coast. So by the time it got to us in San Francisco, pretty sure we had a handle on it.
I recall there being a focus on this mistake of not the computers not being able to update appropriately was tied to Microsoft and their DOS operating system, which by that point was in a lot of systems were based on that. Is that? I guess I'm wrong that it was deeper than that. It goes way back to COBOL. But did DOS came along decades later? Did they not?
DOS came along around 1975.
Yeah.
Personal computer. The personal computer, original personal computers, had the same problems I talked about with the old IBM System 360 and the previous computers. Small amounts of memory. I don't really know how DOS handled a date, but every computer stores the current date, which right now is April 19th, 2025. I know that because my computer has an internal date storage. And DOS, they stored that date probably in something similar to what I showed you. I don't really know. Interestingly, Digital Equipment Corporation, which are the computers that I did most of my work on, when they introduced, not their first computers, but at one point when they came up with the VAX computer system, they used a 128-bit date. Remember, a binary byte is 8 bits. They used 128 bits. Every bit represented 100 microseconds. That seems very fast, but that 128-bit representation of the date will last until about the year 31,000. So their internal storage date was already, by 1975, that was good. DOS, which until about, I don't know, 2006 or something, Windows was really built on top of DOS. So yes, Microsoft had to do a lot of work to get that to work. I don't know what they did. I was busy with my own systems, but obviously they solved the problem. So yeah, there was a big problem there. All computer manufacturers, except fortunately for them, digital equipment, all manufacturers had to make some adjustments.
And another issue, this is probably rather obscure or remote. I was thinking of ancient historians who certainly are dealing with dates BCE, in other words, before the year 0. So how would that
By the
be?
way,
What was that?
there is no year 0.
Well,
That's
right.
why the 21st century began in 2001. There is no year 0.
Well, one could debate that, but that aside, I mean, what year was Christ born? But that aside,
It was in the year of the consul of Julius Caesar's nephew, I think. Anyway.
well, putting that aside, yeah, I think that's what was year 4 of the Common Era. But that aside, what about negative dates, which an ancient historian would deal with? So how would, I mean, it's unlikely this is going to come up in modern commercial transactions, but how would that be handled with the current systems?
Well, there was no, I mean, they were pre-Christian. The Jewish have their own date and it starts long.
I'm going to make a plug for my book now.
Yeah.
I have a chapter in which I discuss how the Common Era came to be the Common Era. I'll give you the 30-second version, although I think Esther's smiling there because it's not going to take that short. There was no common dating for the first 1,000 years or so of what's now the Common Era. Jesus was born in the year 750 AOC, ad urbi conditorum, since the founding of the city of Rome. That was the most used date at that time. Unfortunately, well, Herod died in the year 750. When Dionysius Exiguus, Dionysius the Small, tried to calculate the year of Jesus' birth, he was around what we now call the 5th century. He miscalculated certain dates and ended up being 754. Jesus was actually most likely born in the year 4 BCE, what we would now call 4 BCE. You can't call it 4 BC because he can't be born before himself. Although he can try. I'm not God, he could do anything. There were all kinds of other dates. As Pam pointed out, the Hebrew calendar, Jesus was born, I think, in the year 3760, according to the Hebrew calendar. Although basically what they did is they took the age of the prophets and the age of the patriarchs and all the other ages and worked backwards and say, okay, from now we have a date certain, probably the date of the destruction of the first temple, 586 BCE. Let's work backwards. The problem is, of course, the Bible doesn't give exact dates, but they came up with that. There was a whole mini industry in the first 4 centuries of the Common Era, trying to figure out how old was the earth, how old was creation, when was Jesus born on that basis. And part of it was because they didn't really want the millennium. The millennium happens 1,000 years after something. But after the first 100 years or so, and they said, okay, Jesus is not coming back. We don't really want him to come back just yet. We're having too much fun. So they started calculating. He was born in the year 5500 of the year after creation. So the 6th millennium will be in the year 6000, which is 500 years from now. In the year 100, they could get away with that. It was the year 500, 600 or 500, whatever, starts to come up. Oops, we better move it back a little. It's more complicated than that, as always, but that's basically, finally, the Venerable Bede, who's a historian in 8th century, what's now 8th century, England, wrote a history of England, and he used Dionysius's dates to set the dates for when things happen, CE or BC in his case, and AD, and so on. And that over the next 300 years, that became the standard date. The Carolingian kings pushed that date, and by the year 1100 or so, everybody was using it, pretty much. And then when the Europeans started colonizing and trading all over the world, they insisted on those dates, which is why we now have the year 2025, all because of that.
So this is summarized in your book, and would you hold up and give us that title again? I didn't quite get it. It's called, no, what is it?
Not summarized, I went into a lot more detail.
A God of Our Invention, How Religions Shaped the Western World. Thank you. Okay, available at all fine bookstores, I assume.
I wish. Get it through Amazon if you have to, but it's available, yeah. It's on demand, the publisher's still around, so you can get it.
I was struck by the concern and worry that hit when the year 1000 was about to arrive. There's something about that, something else about the mystery of well, this is our digital system because we have 10 digits, but of course it's completely arbitrary. I mean, and we can see how that convention imposed problems on computer coding, but the psychological issue, this just seems to me very strange that people should. What was that?
The Book of Revelation.
What happened? What? How does that enter?
Christ will reign for 1,000 years.
No.
It said what?
Also look at Psalms. 1,000 years in your sight is but yesterday when it is past. 1,000's a nice number in religion, especially Christianity.
I see. So the Book of Revelation invokes that 1,000-year rule.
Yep.
So what happened then when in fact the year 1000 arrived and nothing happened? That is, what was the reaction?
Well, there was a lot of things. There was some relief. There was some concern that, we miscalculated. It's going to be the year of Jesus' death, the crucifixion, 1,000 years after that, or 1031 or 1033. It could be either date. It came and went, still didn't happen. They blamed the Jews, by the way. If the Jews had only converted when they were supposed to, the millennium would have arrived. I'm serious.
What was supposed to happen on the millennium?
Jesus would come back to earth and have the last judgment, and everyone would go to heaven or hell, and the world as we knew it would come to an end. The world never comes to an end in Christian theology. The world as we know it comes to an end. We have paradise on earth. They expect, if you look at Paul, we're getting a field here. If you look at Paul, he talks about we're expecting it to happen imminently. Will rise, and those who have already died will come down, and while we who are alive will rise up to meet them. That's the source of the rapture, by the way.
Now,
rise.
From a rational viewpoint, though, who expects people to act rationally? One would have thought that the major concern would be among people being, when Jesus arrived, sent off to hell for the misbehavior. So I would anticipate that, and maybe there's some way of documenting this, that crimes, misdemeanors, and felonies might have died off or subsided because of this fear of imminent being banished to hell coming in the year 1000. So is there any evidence that in the year before criminality decreased?
I don't know that there was evidence of that. I do know there was evidence that people tried to repent. Now, maybe they committed a crime in the morning and repented in the afternoon.
They were Catholic. They could confess, and then it was okay. They could go to heaven.
But there was a huge amount of repentance. As I said, people sold their possessions and gave them to the poor, thinking that they wouldn't need them in the millennium. That happened, by the way, with the Millerites in the not the Great Awakening, the Great Disappointment in 1844. William Miller decided that the world was about to end, and he persuaded a number of people that this was going to happen, and a lot of them sold their possessions and went out into the field. He didn't want to commit to a date, but finally he did.
Mhm.
And when nothing happened, there was a lot of poverty and a lot of very disappointed people who had to suddenly pick up their lives again. That became eventually the Seventh-day Adventists and the Jehovah's Witnesses, who still believe that it's going to happen. Or
Is
still,
there a good book about that? Is there a good reference on that episode?
Yes, Dan gave a talk about it to the IHS. Dan, is that still on YouTube?
Jim, I guess it is.
Yes.
Yeah, Dan gave a talk about the coming of Christ and how it was postponed over the centuries. Each time someone predicted it, it didn't happen. Well, then it's going to happen later.
Is
And
there a book about this?
no, it's on a YouTube that.
I know, I
Dan made.
realize that, but
Oh, yeah.
is there a separate reference? I have to do better reading than watching YouTube. Dan, is there a good reference?
Read the book.
The book, right?
Yeah, read the book. I guess we 50 cents royalties.
Yes, the book that Dan wrote, which
Oh, that also covers that. Okay,
That's where it all came. That's where I got all this. I spent 7 years researching and writing it,
fantastic.
so I know this.
and I don't know if,
Everything.
Liz, are you active now? You're not, we can't hear you, but Liz has just been researching what the Institute can say as a nonprofit, and I think it's not possible to support a particular candidate, but it might be okay to talk about policies. Is that true?
I
What is-
believe, according to the HNet Council policy, yes, we are not supposed to support a candidate, and also we're not supposed to promulgate propaganda, but yeah, I think policy discussions would be acceptable.
Well,
not sure
we're
about
talking about activity, not discussion. I
Oh.
mean, those idiots that try to do something to Harvard, that's not going to stop them from trying to do something to us just for discussing it.
Well, they'd like to do something to us just for being, but that's another matter. The big
So-
target is right here. We know it.
So Dan, getting back to the subject of your talk, you said that there are some solutions that certain groups, not Bank of America, but others had instituted that are temporary and that they're going to have to fix again sometime soon.
Again, this is, let's say, for example, if you do a date you can write a program that says, if I do a date calculation and it ends up with a negative number, add this to the number to make it positive again. This is a fixed number that lets you get away with it for a while, pushes it forward to 2030, for example, or 2020, or 20 some other date, but it runs out eventually. As I say, the solutions we have now use 4-digit dates, which is good for the next 8,000 years, 79.99 years. But or they use the digital timestamp that digital equipment use, which is good until the year 31,000. But some people are lazy, or they didn't have time, or they didn't think things through. Remember, the computer does what man can think. Dijkstra's phrase is still one of the best descriptions of a computer in the history of computers. What man can think, or what man decides to think, what man bothers to think. So yeah, the temporary solutions. I don't have the details because I worked out a permanent solution, or all of us did. You're muted, Jim. Jim,
So
you're muted.
do we have any more questions pertaining to Dan's subject for today?
I have one, if I may. Hello, everyone. Thank you for allowing me to be here. Thanks, Ms. Liz, a fellow Fillmore aficionado, for the initial invite. I work with the TRIO program, a federal program for college readiness for socially, economically disadvantaged students. You may not have heard of TRIO. You might have heard of Upward Bound. So a big thing for us is FAFSA. And FAFSA has had a poor rollout the last 2 years. We had heard Miguel Cardona talk to us from the Biden administration. But the specific question is, my understanding is that the reason the FAFSA was delayed and a yearly rolled out, the federal free application for federal student aid for students, was they were using COBOL or just an older computer system. And when the FAFSA was renovated, completely renovated, the system just didn't work. And because of that, there was a month's delay 1 year in getting it out, months delay in the next year. And I was wondering if you're able to speak on that.
Yes, well, I skipped over this because I didn't want to get too technical. And when I said a COBOL program can move from one computer to another, that's not completely true. It's certainly true compared to assembly language programs, which can't move from another computer without an emulator. But there's always little tricks to any computer's version, any manufacturer's version of COBOL, or Java and C and other languages which are developed under modern computer science techniques try to eliminate or avoid or minimize the problems in migrating from platform to platform. They don't entirely succeed, but they're much better at it. COBOL was sloppy. If you didn't get that point before, you get it now. COBOL is sloppy. It was slapped together. Frankly, it was slapped together so that business people who didn't read program could read this and say, oh, it looks like English, I understand it. They didn't, but it gave them a warm and fuzzy. And Grace Hopper, who invented COBOL, actually said that in almost some of those words. We want to make the business people happy with the COBOL program. So it doesn't always move that easily. And if you wonder why good programmers all hate COBOL, that's a good reason. But yeah, but any program is going to have problems moving from one platform to another. There's always a few idiosyncrasies. There's always a few things. Sometimes it's done deliberately, like when Microsoft writes Windows 11, it won't run on an old computer. You have to buy a new one. That's cheating. But sometimes, yeah, there are computer advances. You want to be able to take advantage of some new function the hardware gives you. In theory, an older program could run on that new computer without bothering to take advantage of it. In practice, it's more complicated. You see, I wouldn't want to get too technical about it, but that's why it's hard to move things from one to another. And that's why it takes months of testing to make sure things work. And for that matter, whenever the bank, after months of testing, and we did thorough testing, we were known for it. Whenever we moved a new iteration of our banking systems, this was a money transfer system, we upgraded to a new version of it. People like me had to stay on call for about 3 days, just in case something went wrong. And we always wrote fallback procedures. If when we put it into production, something goes so wrong that we can't sustain it, we have to be able to fall back. And at least in one case, we did. This is what responsible programming looks like, which is why I don't trust Doge. Move fast and break things is not a way to program.
Thank you.
Can you talk briefly about Apple, or do you know anything about Apple? Is it running?
Not very much.
Yeah. You know what it's running on?
All of the jobs I held, including with the State Department, used PCs and Windows. So I always kept Windows at home. I didn't want to transfer. Jean, my wife, has an Apple computer. She likes it. I frankly don't, because Apple was originally designed so you didn't have to know the guts. You didn't have to know what's going on inside. Well, that's my profession. So I like to know what's going on inside, and I find it easier to work with Windows from that perspective. I can't tell you very much about Apple.
Apple runs on its own operating system. It's unusual in
Okay.
having being both a software and a hardware company.
Right.
Yeah, let me explain something that Jim brought up. All computers have an operating system which is unique to that type of computer. That's Windows, that's OS, that's operating system 360, that's all these other things. This is what runs the guts of the computer. This is what keeps everything moving. It's a controller. Application programs are like what the bank wrote to handle money transfer. It's like Social Security programs to handle Social Security accounts. It's like mortgage programs. Those are all applications. Those can theoretically be moved from one computer to another. Operating systems are written for a specific computer. And nowadays you can sometimes move them, but not really. So Apple writes its own operating system. Windows writes its own operating system. In theory, you can run an application program on either Windows or Mac. But in practice, some people, you have to write different versions.
So they write a different version of Word, for example, and that can
Yeah.
be played on Mac, but it's a different.
Yeah.
Yeah.
You can write a version of Word that will run on Windows 9, Windows 8, Windows 10, Windows 11. It'll run on the same thing,
Mhm.
but you want to write a version, you want to run that Windows on Mac, you kind of have to change it. I think some programmers are trying to design programs that will run on either without changing, but it's not easy.
Yeah. Thank you.
And you wonder why programmers get paid a lot.
Mhm. Sigh.
Okay, so are there any more questions for Dan? Comments, or Dan, do you want to talk about next month?
Yeah, I haven't sent it. Thank you, everybody. I haven't sent next month out yet because it would confuse people about this month. But let me just pull this up for a second.
While you're doing that, why don't I
I appreciate that.
thank you, Dan, for your enlightening presentation, and obviously you know your stuff from 1 to 0.
Oh, it's
0 to 1.
Atlas will be talking about football and technology, the essence of the Bay Area. And I'll send this out as soon as this session is over. It'll be May 17th at 10. We're gonna do Saturdays. And he's going to talk about the Bay Area development of football and development of technology. They're not really connected to each other, but they came around at the same time. So it's up to him how he's going to do it. I've got the flyer. It's going to go out in 10 minutes. So thank you all. Have a very good weekend. Remember, there are 501 protests. I'm not supposed to say that, but there are demonstrations going on all over the country this weekend. It's a nice day out.
All right. Yeah.
Liz,
Thank you.
hopefully
Thank
we
you,
will
Dan.
have the statement out sometime soon, I hope.
I still need to hear from a couple more board members. And yes, once I hear from them, I will send out the statement to the general membership. Thank you. But thank you for your work on the IHS statement, and appreciate it, along with Peter and Lewis.
Thank you.
I see something came up in chat. Why was Sylvester II accused of consorting with it? Because he was an intellect in an age when intellect was not well appreciated. As someone pointed out, he could use the abacus.
Well, somebody answered that he was suspected of being,
That, but I didn't. But I don't think everybody saw it. So I'm just looking at it, explaining.
but
Yeah, he was a scholar.
what was he, was it astrology or,
Alchemy.
Alchemy.
He probably was astrology, was a science even in the 1700s.
but what was it
But
specifically?
believed astrology,
Alchemy.
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 But why was alchemy seen as consorting with the
Because he
devil?
was smart. He was smarter than everybody. Therefore, the devil must have been helping him. You want logic? I'm sorry, you're on the wrong planet.
No, but I'm not aware of that as a historical theme. In other words, aware of superstition, say witches, um, animosity to Jews, for various intellectual purposes, but I've never been aware of this, of an anti-intellectual bias of that type, where suspicion is.
Look at the Know Nothing Party in the 1840s and 1850s. Read
Trump, who says, I love the poorly educated.
Who said that?
Trump.
Trump, I love the poorly educated.
But you
Hofstadter
vote for him. That's something else.
in America. Also consider this, popes have enemies.
What? Popes? Oh, yes. I mean,
So
the popes have their enemies, but all right.
the fact that he was an intellect, he was brilliant. He could talk about things people didn't understand. That made it a very useful target, a weapon for his enemies.
All right. Give me another example from history of an individual, like, I mean, Bacon, for example, was not subject to that kind of reaction.
Galileo was.
Frankfurt, fortunate, he lived in the age of enlightenment when people respected that.
Look at
Galileo was told.
Galileo.
Galileo.
But that was different. Galileo, because he specifically refused to concede theological authority. But is there, I'm just trying to think of.
I'm sorry, you're coming close to the no true Scotsman fallacy here. Galileo,
Which fallacy? Which fallacy?
the no true Scotsman fallacy.
I'm sorry, I don't quite gather that.
No true Scotsman. Scotsman sees in a newspaper that somebody was accused of killing of murdering his wife and slicing her into bits. And he said, oh, no Scotsman would do such a thing. Next day, he opens up the paper and finds another person, this time a Scotsman, has been accused of the same thing. Said, oh, no true Scotsman would do such a thing.
Right.
It's called the no true Scotsman fallacy.
I never heard of it. But
Okay, well, the point is, you asked for an example, we gave you one, Galileo. Now, Galileo made a lot of enemies. It's not so simple.
Nicholas Bruno. I mean, and the alchemists
also made enemies.
Yeah, the alchemists.
Copernicus didn't publish on his deathbed, as some people say, but he did hold off on publishing his theories about the heliocentric universe until the last year of his life because he was afraid of what the church might do.
They told Galileo that the Bible clearly says that the sun comes up in the morning and goes down in the evening. Now, how can the Bible say that if the sun doesn't move?
The problem was that Joshua, where the sun didn't move.
Well, that's a problem, but
held everything up. But
again, you're talking about a specific.
You asked me for specifics.
Yeah.
Okay, here's another one. Augustine said, a feeble curiosity is dangerous. He didn't like curiosity because it takes men away from our prayers.
All right.
Okay.
And did anybody follow Augustine? And
a lot of Augustine was the prime doctor of the church. Even today, the church likes to follow Augustine. He was the head of. Until Aquinas came along, he was everything, and Aquinas built his theology on Augustine's theology.
So so Augustine was the godfather, so to speak, of anti-intellectualism. All right.
Oh, he was a major force in it. I wouldn't say he was the godfather because.
And of course, we're talking about men. Women were not supposed to have an intellect.
Well, they did, but it came from the devil.
Right. So I just read The Woman Who Could Not Be Silenced by Kate Moore. I want to talk about it in the women's group. And it shows very clearly that the path to intellectual liberation for women came directly through the asylum, because husbands could very readily have their wives sent to an asylum for talking too much, thinking too much. And they were.
Who was the
Abigail Adams. Her husband respected her, but she could only get her ideas through to the founding fathers through her husband. She would write to him. We have the letters, and he appreciated what she said. but she had to do it indirectly because women's intellect was not respected. The Inquisition, when anybody who challenged the Inquisition, anybody who challenged church